going to talk about volcanoes and how they appear.
We'll present through the background of volcano eruption, focusing on Earth's structure and tectonic movements.
Later, we will demonstrate an eruption showing you a model of a volcano which we have made.
Now we're going to the University of Oslo to visit Professor Fernando, who will tell us more about volcanoes.
Hi, we're now at the geology building at the University in Oslo, and as you see here, we have some rocks. What are you working on right now?
Right now, I do dating. Hi.
Trying to hold back this feeling for so long. And if you feel like I feel, baby, then come on. Oh, come on. Woo! Let's get it on.
What we are especially interested in,
Yeah.
and what we have chosen to base our project on,
Yeah.
is volcanoes.
Okay.
And the making of volcanoes. So in the project we also made a model,
Yeah.
and we know the basics of how the plates, one goes under the other,
Yeah.
melts, and the magma,
magma.
yeah,
Yeah.
comes up and forms a volcano.
Yeah.
But that's the basic. Yeah.
But then there are the other type is what's happening now in Hawaii.
Yes.
Yeah, this Mauna Loa, I think, that is erupting lava and explosive. And there you have no plates. There you have a hot spot. You see Hawaii is out in the middle of this huge Pacific plate.
Yes.
And there there is nothing, there is obviously no subduction at all. So that is coming from a plume, so very hot material that comes from very deep in the mantle, and it erupts. So this is the core, a cross section. So the core, and so the outer core is liquid, the inner is solid, and then you have this boundary here, which is there are two main masses which have a low. They see it with the seismic waves. So the speed of the wave depends on the density of the material, and so this is called low shear velocity. So it's a bit a different composition than the rest of the mantle down there. So they pick up these masses. This is where the plumes start up. So the material descends here. So here you have one of these subduction zones. So the material is brought down, and eventually it melts up, or it starts moving up. It gets lighter than the surrounding material until you form these plumes. And here you have Hawaii, and there is a chain of volcanoes that you can trace back, and it goes like this. And this is they are erupting today. The news, and they get older as you go down here. So I think they get up to 90 million years or something like this. Which means this plume here has been steady, hasn't moved, but the plate has been moving. So the thing has always been at the same place, but the plate has been moving up.
Yes.
Now we have been at the University of Oslo visiting Professor Fernando. He has taught us a lot of interesting things about volcanoes and especially hotspots.
The Earth was made 4.6 billion years ago when the floating mass started to set little by little. Our round globe consists of different layers like inner core, outer core, mantle and crust. And the crust is made up of tectonic plates which are in constant motion because of convection.
Convection is the movement in a gas or liquid where the warmer parts move up and the cooler parts move down because of the density in the liquid decrease. Due to these movements, the tectonic plates will move around the Earth's surface.
Tectonic plates can move in 3 different directions. When 2 plates move away from each other, an ocean ridge or continental ridge forms, depending on whether the plates are under the ocean or on land. This is called divergent plate boundary. When 2 plates move against each other, this can lead to an earthquake. This is called transform plate boundary.
If 2 plates collide and neither of the plates goes under the other, the plates will just crumple and build up mountains. This process does not make volcanoes.
When an ocean plate and a land plate collide, the ocean plate will go under and sink into the mantle because it's heavier. This process, called subduction, typically forms a trench in the ocean floor. As the ocean plate pushes down into the mantle, it heats up. The increased water content lowers the melting point of the mantle, causing it to melt into magma. This sort of magma production is called subduction zone volcanism.
As we said, ocean ridges appear when 2 plates move away from each other. The magma produced when 2 ocean ridges just hardens to form new crust material, and so doesn't produce sweeping land volcanoes.
When the solid rock changes form to a more liquid rock material, it becomes less dense than the surrounding rocks. Because of its density, the magma will rise up. On the way up, the magma will melt more till it becomes a mixed magma mass.
The magma keeps moving through the crust. At this point, the magma collects in magma chambers below the surface of the Earth. If the magma pressure rises to a high enough level or a crack opens in the crust, the molten rock will spill out at the Earth's surface.
If this happens, the flowing magma, now called lava, forms a volcano. The structure of the volcano and the intensity of the volcano eruption is dependent on a number of factors, primarily the composition of the magma.
Volcanoes vary in their destructive power. Some volcanoes explode very violently, destroying everything in a mile radius in only a couple of minutes, while other volcanoes pour the magma out slowly and you can safely walk around them. This depends mostly on the composition of the magma.
The erupting force generally comes from the internal gas pressure. The material that forms magma contains a lot of gases. Yes!
What you get is magma filled with tiny gas bubbles, which have much lower density than the surrounding magma, and so push out to escape. This is the same thing that happens when you open a bottle of soda.
When you decompress the soda by opening the bottle, the tiny gas bubbles push out and escape. If you shake the bottle first, the bubbles are all mixed up in the soda, and a lot of more soda will come out. This is true for volcanoes as well. As the bubbles escape, they push the magma out, causing a spewing eruption.
We have used this example to illustrate a volcano eruption using a soda bottle to demonstrate the magma. Most land volcanoes have the same basic structure, but they can vary in size and shape.
Wow!
That was amazing!
Did you see that how volcano just erupted?
Yeah,
That was cool!
that was
Yeah!
amazing, yeah.
Did you guys see that?
Yeah.
Jeg tenkte det skal se litt kult ut. Jeg trodde vi tenkte å ha det her i slow-mo.
Ikke si det her. Chill, boy.
The eruption depends mainly on the gas content and the viscosity of the magma.
As a general rule, the most explosive eruptions come from magma that had high gas level and high viscosity, while the most subdued eruptions come from magma with low viscosity.
When a volcano erupts, the lava.
Okay, so that was it for today. I hope you guys learned something new about volcanoes and that you enjoyed our movie. And don't forget to leave a thumbs up and hit the subscribe button down below. Stay tuned!